good. Something's going right today, so I'm not 100% lost. So, hello. My name is Andrew. I am here to talk to you a little bit about Docker containers and why you should totally do Docker all the time for everything forever. Hopefully, if you're in this presentation, you know a little bit about Docker. Maybe you've heard of it. Maybe you've used it to set up some developer environments. If you've deployed some things on Kubernetes or Swarm or Redshift or whatever else, I still think you'll find some valuable information here. Certainly come up with some good questions. I love the hard questions because they're interesting. If you're homebrewing your own cluster and deploying it on AWS, you are going to be bored. I can't help you. I'll see you later. So, please interrupt if you have any questions. The goal is to have a cool conversation. It's not to stand up here in front of these slides. I did spend lots of work on them, but honestly, you're more important. So just raise your hand, ask the question, I'll repeat the question back to you, and we'll have a discussion. Same deal, if you know about this topic, I know we have a lot of Docker enthusiasts here, and you feel like you have something to contribute, please do so. So, to get started, hands up who's responsible for production. That means deploying things, managing things, moving things around in a production way. Awesome. So, keep your hand up if you're responsible now, out of curiosity. Yeah. Keep your hands up if you've broken production. Yeah. Me too. So the problem is basically production. The problem is that building a server is hard, managing servers is super hard, managing servers for years on end is particularly hard. I have some beautiful horror stories about things I've found on servers. But managing like 30 servers, we have probably 30 servers across different clients, different services, things like that. It gets to be a ton of work. Things will get missed. Broadly, that's the problem that containers try and solve. So, the solution is containers, Docker. Who's used containers, just out of curiosity? That makes sense, we're at a Docker talk. Keep them up if you've used Kubernetes. Yeah, that's cool. Are you deploying to prod on Kubernetes? Not just yet, that's cool. So, this is what it looks like. Broadly, the blue stuff is the containers. The pink stuff is Kubernetes. Don't worry too much about all this, we will cover it in more detail, but here is the bright and shiny future that we will hopefully get to. What does that say? Oh, live demo gods. So we're going to try and install Magento live right now, and I don't know how it goes, but we'll see what happens. Here's one I prepared earlier. Yep. Awesome. So we just installed Magento. It will take maybe 4 or 5 minutes to install, pull in databases, manage a few different things, but that will come up and running in the next 3 or 4 minutes. So if you're curious and you want to double check my work, please do so. Take a picture of that now. I did prepare, oh, hang on, the slide is broken. Here's one I prepared earlier. I did this while I was sitting just there and I was panicking a little bit because Magento takes a little while to come up and running. So I also did WordPress. WordPress was much faster and much easier. I know that's a Magento conference and sacrilege to say, but take a look at those if you're curious as to how this stuff actually demonstrably works. So, containers. Containers, just as a brief history, have been around since the early 2000s. They're a combination of two very stable Linux features called namespaces and cgroups. Broadly, they're just a way of isolating processes on a machine. So if you've got Apache, for example, or PHP, you would have heard of jails. People in shared hosting used to run them on jails. This is an extension of a similar sort of technology. They isolate them in terms of you're only able to see processes from that you're supposed to, only able to see the network that you're supposed to. They're just a bunch of Linux magic to separate processes. Cgroups allows you to prevent one container interfering with another container, which is really handy if you're running 20 containers on a single machine. You don't have Jira, for example, eating Magento's resources. Docker. Docker is comfortably the best wrapper around containers. Interestingly, it's not the only one, and more in production, particularly in Kubernetes, they're moving away from the use of Docker because it's a lot, and we only need a very small thing to run containers. But if you are just learning this technology, please go and explore it. They do some really nice stuff. Docker Compose is particularly excellent to play with. So, who's played Snake? Does anyone have those like old Nokia phones that you used to be able to... Yeah, that was me. So, we're going to do the fun part of this component with Snake. Broadly, Docker looks like any kind of CI/CD build pipeline. You build the image, you stick it to a repository in some fashion, and then you ask it to be deployed somewhere into the cloud. That's what we're going to build. It's Snake. It just pulls in Snake in an Nginx container and like runs it. It's pretty straightforward. I'm not going to live demo this one because I demoed it earlier, presuming we have internet connection. YouTube's good. So that's what it looks like. It's super straightforward. Docker will do some cool magic around caching the different layers of the image, so we're only just adding the required stuff to run Snake. This will take probably 2 or 3 minutes, and we'll end up with a container. So we'll skip ahead because this is pretty dull. You can see it's installing a bunch of app stuff. The next step is to push. Now, containers are particularly exciting because we take this deployable artifact, which is something you don't get with many other systems, EC2 being one, but it's a pain, and we stick it somewhere. And when you stick it somewhere, you can do analysis on it. You can do things like determine if there's any security vulnerabilities in it, determine if the software is out of date, determine if somebody's misconfigured something. So take this deployable package, stick it in a repository. This particular one is called Key by a company called CoreOS, Red Hat now, and it's really good. So. It looks like this. It's thinking. Right, so we'll skip ahead, that's fine. Basically, it just takes the image and puts it into this repository. You can actually check this out. It's key.io/littlemanco/snake. That's fine, we'll skip ahead. And then we deploy it. So we take this artifact that we stuck into a repository and we copy it back down onto another machine and we run it. Which we'll skip ahead because the internet's having a bad day. So the cool part of this presentation is deploy it to what? Now, Docker is a really cool technology. It's not the whole picture. The rest of the picture is the actual deployment lifecycle where you deploy it to. Kubernetes is becoming the de facto solution, and if I could have one thing to take away, I would say, please take the time to learn this. It will be hard. You will probably suffer a little bit, but it's worthwhile in the end. It's used by basically everybody. Most of the Fortune 500 companies are playing with it at this stage. Google invented it, Azure, Google Cloud, and AWS. It's a bit embarrassing. All have hosted services. You can just pick a cluster and run it. It's really handy, really easy. So we've covered now the blue stuff and the pink stuff. We'll go through a bit more in detail how the pink stuff works, because it's interesting kind of getting an understanding of where that all fits in. Traditionally, we actually have hosts still set up like this, which caused me some misery. You have maybe 3, 4, 5 machines. So one machine, you'll say, I'm going to put this software on it, and there's going to be the Magenta machine, the front, the web node, whatever else, blah, 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 blah. On the other machine, you'll stick maybe some ancillary services, Graylog, Elasticsearch, the rest of the stuff that makes your app debuggable, and on something else entirely that you just have and never maintain, you'll stick Jira so your project managers don't freak out. The new way is basically you deploy this same software, exactly the same stuff, but you deploy it to Kubernetes. And it doesn't really matter so much which machine you put it on. So in this case, you can see MySQL's over there, Magento, Redis, Graylog. They all just get mixed in. Across the same machines, it's nice and secure, it's all lovely. Which is cool, but a little complex. So what is that bias exactly? So the nice things it buys us are we don't have to make decisions anymore about where to put software. As I said before, we have 30 machines. The majority of those machines don't do anything most of the time. Either the sites are idle, no one's happening with a particular service, the service is only required for an import job. So we can just delegate all of the software placement machines to Kubernetes, and it is extremely good at placing that software. Next thing we get is service discovery. We don't have to wire up DNS records. We don't have to make sure this service is able to communicate with that service through the firewall. We don't have to coordinate anything, essentially. We just say, look, here is a container, and we want to be able to talk to that container. Please go and magically sort it out somewhere. The concrete details of this is it does work on DNS, but Kubernetes handles the setting up and managing of those DNS records. And the part that I like the most, because I am the one who has to wake up at 3 in the morning when things break, when things break, they automatically recover. And they automatically recover in a couple of ways. Usually the service is just restarted. All services are health checked. And in the worst case, when a machine dies or when an upgrade rolls through, Kubernetes will pick up that software, move it to another machine, and restart it. So even your underlying physical hardware doesn't matter so much. Last thing is horizontal scalability. Honestly, I haven't played with this one too much yet. But you can take one container, you can scale it up to 10 containers, 20 containers, 30 containers. It doesn't really matter. Go as far as you want based on CPU or based on custom metrics like queue length of the requests or something like that. Application bursting. This is super nice. If you've got 10, 20, 30 services, they don't all use CPU at the same time. Maybe Jira will use lots of CPU in the morning as it's doing an indexing job. Magento will use it as admins and generating reports. MySQL will use it for reasons, just because it's MySQL. They don't all take CPU at the same time. So if you're able to put them all on the same machine, the applications can borrow the allocations of other applications. So say, for example, Magento is running a report. It will say to MySQL, look, I need more CPU. MySQL goes, yeah, man, I'm not using it. That's fine. Go nuts.
Is it the same machine, or it's available to share between like different machines?
Just the same machine.
Oh.
Yeah. If we'll fall back to the normal allocation you give it. So in this case, we've given it maybe 25% allocation to Magento and 75% allocation to MySQL. If they both want to use them at the same time, they will get restricted back to their original allocations, and you're rate limited on CPU as you would like an EC2 or anything else. Extensibility. So once you start getting pretty comfortable deploying and managing software, you will start to build services that in turn build and manage software. One of the earliest use cases that I will find for this is TLS certificates, SSL. Kubernetes gives you a description to, or gives you a language to describe additional services, things like TLS, like backups, like all of this sort of stuff that happens and that you need to do, but also kind of happens after the fact. So you can write a declaration, you write something to fulfill that declaration, and it just sort of magically works on top of this deployment framework. Does a bunch of other cool stuff, which we're not going to talk about. It does all of that kind of thing. It's not something you get used to until you start playing with it. Again, if I could get the message across, take it, start playing with it, start learning it. Hit me up on Twitter and I'll help you out with the inevitable, what this doesn't work like Yusuf does. So, that's all magic. It's not actually magic though, so let's explore a little bit how it happens. So there's 4 processes to Kubernetes. Kubernetes is not like one thing, it's a few different things that all work together. We have the kubelet, so that's kind of like the Docker host on each machine. It just takes and runs Docker containers. That's it. The scheduler decides where each container runs, and it will decide where each container needs to run in the case of failure. So one container will failure over there, maybe it keeps failing, keeps screwing around, it'll move it to another host. The API server is what you talk to. That's where you can set up your new declarations in, that's where you create services in, that's what you generally, that's like the AWS engine bit of Kubernetes. And the controller manager makes sure that everything remains as it should be. So it will continue to go through checking the health of each service, make sure everything is correct, make sure that scheduled jobs have run as they should, handle error behavior when things don't run as they should, and generally make sure things are kept in the peace. That's the thing that replaces my job. It works by setting a declaration. So if you've used Ansible or similar sort of infrastructure as code tools, Terraform is another one, you'll be used to this idea that you write a specification and then you hand it off to the software to determine how to make that specification a reality. Exactly the same thing happens in Kubernetes. You say, look, I would like to run one copy of Nginx. And Kubernetes will say, great, I'll make that happen for you. And it will do a whole bunch of reconciliation internally to make that desired state actual. It does this through control loops. Basically, this is climate control of your computer. It just detects the current state and will make adjustments to make sure that the current state reflects the actual state. Rest and repeat, check the current state, make sure it's the actual state, over and over again. Yeah, exactly that. That's it. That's the whole magic. You now have a crash course in Kubernetes. If it doesn't make sense, that's fine. Come talk to me later and we'll sort it out. The last thing we should cover is the kubelet. That's the thing that actually runs the jobs. It's super dumb. It says, I would like to run a container, and you go, great, and that's it. But this talk was called Fun and Profit. So Kubernetes actually makes a difference to the way your business does cache. It made a difference in terms of Squarespace. They were able to take their deployment process and modernize it, so deployments were much less overhead. Their savings were 85%. There you go. So they are just able to push more code more easily. Crowdfire. Because the way Kubernetes works, it does its own internal load balancing. That means they're able to cut a bunch of the AWS services, and things just run more easily, more quickly with the Kubernetes primitives. And Wikimedia is probably my favorite example. They're a company that works almost entirely by volunteers. Their labor is all volunteer labor, which means their code is of, shall we say, varying quality. It was difficult to run all of this code together across their same set of systems. So in the end, what they decided is if you can pack it into a Docker container, look, we'll run it, that's fine. And this became their common deployment framework. In terms of an agency, this is really exciting because it means you can explore and test and experiment without needing to retool your server or management infrastructure. You just say, look, again, pack it into a Docker container, I'll run it, that's fine. So, summary. Containers are pretty good. Kubernetes is super good. It's complex. When you first start learning it, this stuff's going to hurt. We started experimenting this with 2 years ago, give or take, and we're now starting to roll it out to production. More and more team members are being qualified as certified Kubernetes administrators. That's like the Magento certification of Kubernetes. And we're getting there, but it's pretty hard. Google Cloud were the first service to provide managed Kubernetes. Makes sense, they invented it. And they do a really, really nice service where you can just say, look, I'd like a cluster. They'll just charge you for the underlying VM infrastructure, not the cluster management stuff itself, and it works really quite well. It powers the Pokemon game, Pokemon Go, the recent one, yeah. And if what I say doesn't make any sense, that's perfectly fine. I am Australian and have a very thick accent and a very quick speech. These people are all excellent people that you can go and find more information on. Particularly Jess Frizzell and Kelsey Hightower are people that I've learned a tremendous amount from. So, do you have any questions? Queries, comments, or reviews? Yes?
Well, thanks for your presentation. Do you recommend it to use when you have not so big infrastructure, for example, 1, 2, 3 servers?
Mm-hmm.
Is it worse? Because as I understand, it's more enterprise things with internal networking management and etc.
It depends, like all things. So yes, broadly, I do recommend it as a common framework for at least our company. The reason for that is because eventually somebody still has to be responsible for this stuff. If you've got 3 servers, somebody's going to have to be making decisions around which goes through what, debugging them as they talk to each other, making sure that each server comes up, comes down, gets updated, stuff's around. There's still management in terms of even 3, 4, 5 servers. If you can delegate that to a system that's responsible for handling that, that takes some of that pain away. That pain just goes as a better investment the more servers you have. So, yeah.
Second question about the deploying of the code.
Yeah.
Containers is responsible for deploying the program, processes, but what's about that content? Static content of code or etc. Has it some practices for that?
So do you mean for example, with Magento, do you bake the Magento application into the container itself? Yes, I recommend you do that. The containers are pretty cheap. You can build the base container full of Apache and mod PHP and whatever else. And then just drop Magento in on top of that. You're going to have to be shifting Magento over the network anyway. It makes sense to bake it in with a container. The other thing is you can remove some of the craziness around deployment. The weirdest ones we have are usually network ones when you actually install something or when you try and wget something and a network path times out, then your deployment goes sideways and it all falls apart. So if you're able to pack it in the container, it's a dumb tarball. Take it, release it, ignore it. Awesome.
Thanks.
Any question?
You use Google Cloud as an example of a system which gives us Kubernetes, but what's cost compared to normal virtual machine in Google Cloud?
Zero.
Zero. So it's the same for the same machines, yes?
Yeah, they don't charge you for the control plane. They don't charge you for Kubernetes at all. They did, but they dropped it when AWS bought their Kubernetes product out.
Okay.
Yep.
I have two questions. One is, can we see what happens with your Magento installation?
Yeah, we should have a look.
And the second is, had some problem on the Docker with debugging. Is it just our problem we need to solve, or is it just a general issue?
What was the problem?
Just debugging when you show that, like, prove the breaks.
Oh, I see. With Xdebug?
Yeah.
Yeah, so Xdebug on, so where you have Docker on Windows, Docker on Macs, and Docker on Linux, Docker on Windows and Docker on Mac both run in a virtual machine, which means the network path is not directly from the container back out to your host. It means you need to go set up a tunnel or generally something else. Docker on Linux runs directly on the host, so it's just a straight network path out. It is historically a difficult problem. I don't have a lot of experience debugging Windows and Mac because I run Linux. Yeah.
These newer versions of Docker for Windows and Mac, they have a host name, docker.host.internal, which you can use to connect back. And if you
Nice.
do the configuration as a remote host, then you get automatic connection.
Do you mind if I repeat that?
Please do.
So Docker on, this is news to me, so I'm enjoying this. Docker on Mac and Docker on Windows have a host that you can connect back to that will route back to your host called, what was it?
I think host.docker.internal, but maybe the order's different.
Some magic to get back to your host. Any other questions, queries, comments? And then I'll have a look at that presentation. That's it for me. Come find me if you have any questions. I enjoy discussing very nerdy things like containers and monitoring and Prometheus and that sort of stuff. I will leave you here.